So in this video, I'm going to look at the concepts of rationalizability and iterated dominance. The concept of iterated dominance refers to the successive deletion of strictly dominated strategies in a normal form game. So the underlying assumption is that all players who are playing the game behave rationally, meaning they choose those strategies that yields or results in highest payoff for them. And they're also assumed to have common knowledge about the game. So let's say you and your partner are playing the game, then it's a common knowledge between you and your partner that both of you are rational. And you understand exactly the game that is being played between the two of you. So basically you're saying that you and C both know the matrix that describes the game. C knows that you know this. You know that C knows this. C knows that you know that C knows this, and so forth. All right, so those are the underlying assumptions. Now, so when players behave rationally, so they don't play any dominated strategies, because dominated strategies, if you remember, will result in lower payoffs, right, relative to some other strategy that the players have. So rational players are not going to choose to play a dominated strategy. So we can pretty much assign a probability of 0 on those dominated strategies in a game, meaning those strategies will never be played by a rational player. So you can strike them off from the game. And then you will have a reduced form game because you're striking off certain strategies that are dominated, right? So that will reduce the dimension of the game. And then in the reduced form game, again, you're going to look for dominated strategies for any player, and then you strike them off again. So this is what we mean by successive deletion of strictly dominated strategy. So in many cases, this procedure will result in a single strategy surviving, and that could be considered the outcome of the game. So the strategies, the set of strategies that survive the successive deletion of strictly dominated strategies are called the set of rationalizable strategies. Okay, so let's write it down. So the strategies that survive the successive deletion of strictly dominated strategies are called the rationalizable strategies. Okay. All right, so let's try to understand this procedure, the iterated dominance and the rationalizability. So let's consider a game. So let's look at a game. So let's say it's a 2x3 game being played between two players. So let's say, okay, so let's say player one has two strategies, play A or B, and player two has three strategies, play X, Y, or Z. And the payoffs are, let's say, 3 and 3, 0 and 5, 0 and 4, 0 and 0, 3 and 1, 1 and 2. Right? So in this game, you can right away, let's see, you can strike off the strategy X for player two. Player one knows that player two will never play strategy X because it is dominated by strategy Z, as you can see, of player two. Player two, when C plays Z, as you can see, C gets either 4 or 2, depending on what player one chooses, right? A or B. But with strategy X, player two will get 3, player one chooses A, which is inferior to 4, and gets 0 if player one chooses B, and which is inferior to 2. So clearly, player two will not play X. So player one knows, player one knows that player two is a rational player, right? And therefore, player two will never choose X. So we can delete this strategy of player two. So now we have a reduced form game, right? So the first, deletion resulted in a reduced form game. The game now has 2 by 2 dimensions. So let's write it down. So now we have this 2 by 2 game. So players 1 and 2. So we have A and B still surviving in the game, but now we have only for player 2, Y and G. X has been deleted, right? So you have a reduced form game. So now the payoffs are still the same, 0 and 5 here, and 0 and 4 here, and 3 and 1 here, and 1 and 2 here. So now what we can do is, in this reduced form game, right, let's see if any strategy for any player is dominated. So now you will see that for player one, strategy A is dominated by strategy B, no matter what player two does, because A gets 0 in it doesn't matter whether two plays Y or Z. And if player one plays B, he gets either 3 or 1, which is strictly better than playing A. So clearly in this game, now we can strike off the strategy A for player 1. And now we have a reduced form game after the second deletion of the dominated strategy. So the game now has 1 by 2 dimensions here, right? So player 1, 2, we have Y and G, and for player 1 is just B, okay? And so 3 and 1, and 1 and 2. So now, as you can see, since both players are rational, so player 2 will not play Y, because Y will result in 1 and G will result in 2. So in this reduced form game, we can strike off this strategy of player 2. So the game is reduced to now just one dimension here, one cell here, right? So this is the outcome of the game through this iterated dominance procedure. So the set of rationalizable strategy is a singleton set B and Z. So you can say, you can write it as player B, player 1 has B and player 2 has C. So it's a product of the two, right? So this is your set of rationalizable strategy. This survives the iterated deletion of dominated strategies. All right. Okay, so next, let's consider another game just to, illustrate this concept of rationalizability, right? So let me add another page here. All right, so let's consider a different game. So in this game, we have it's a 3x3 game. So we have two players, 1 and 2, and player 1 has 3 strategies, U, M, and D, and player 2 has 3 strategies, X, Y, and G. And the payoffs are, let's see, 5 and 1, 0 and 4, 1 and 0. And 3 and 1 here, 0 and 0 here, and 3 and 5 here, and 3 and 3, 4 and 4, and 2 and 5. So in this game, you should realize that player 2's strategy X is dominated. It may not be evident right away, but if you look at strategy Y and Z for player 2, you'll see a mixed strategy where 0 probability on X, 1/2 on Y, and 1/2 on Z will dominate strategy X, right? So you can see, a combination of Y and G with probability 1/2, 1/2 is strictly better than player 2 playing X. So we can delete strategy X from this game, okay? And then so now we have a reduced form game, right? So let's look at this game. So let me write it down here. So we have 3x2 game left, right? So Y and Z, and up, middle, and down. And so we have 0 and 4, 1 and 0, 0 and 0, and 3 and 5. And here we have 4 and 4, and 2 and 5. So now, as you can see, strategy up for player 1 is dominated by strategy down, D, right? Because 4 is better than 0 if player 2 plays Y, and 2 is better than 1 if player 2 plays Z, right? So we can strike this off here. So now we have a 2x2 game, and in this 2x2 game, you can clearly see, I don't even have to write down a 2x2 game. We can just continue with this, same game here. So here you can see that player 2's strategy Y is dominated by strategy Z, right? Because G results in 5 for player 2, no matter what player 1 does, and Y results in either 0 or 4. So clearly, this strategy is dominated, right? And then what happens is we have a 2x1 game left, right? And in this game, you can see that player 1 player one is not going to play down because player one will get 2, and if player one plays M, he'll get 3. So clearly D is dominated. So this can be eliminated. So you're left with just M and Z. So that is your set of rationalizable strategy here, right? So that's what survived the iterated deletion of dominated strategy. So the set of rationalizable strategy is M for player one and Z for player two. So this is the outcome of this game. Now keep in mind that the both games we have considered so far here, we were able to delete, the dominant strategies, and eventually it led to a one single, strategy for each player, right? But it's possible in many games that you may not be able to eliminate all the way to one single strategy left surviving, right? So in that case, if you have a 2x2 game left and you can't delete anything further, then this 2x2 game will become the set of rationalizable strategies.